Guys, I take it you figured out that the notes are pretty short, right? Guys, how's power rule coming along so far?
Good.
Is it important to rewrite functions so you can apply the power rule?
Yeah.
Okay, now things I don't want you to lose sight of today, although we're going on to some new rules. Don't lose sight of the rules that we've already talked about, okay? So we've got to be able to understand the difference between power rule that we've been exposed to the last few times that we've looked at stuff. We're going to start comparing what derivatives look like from power rule to today we're looking at derivatives of what type of functions. Okay, here's a question for you. I'm going to put two functions up here. Whoops. Guys, which function is the power function?
X to the third.
X to the third. This is my power function because we have a number out here, all right? You know the power. So what kind of function is this?
Exponential.
Exponential. Which one of these do we already know how to take the derivative of?
Power.
The power function. What would the derivative of x to the third get you?
3x to the second.
3x to the second. So my question becomes this: what's the derivative of an exponential? And that's what we're going to talk about. We're going to talk about what are the rules of those today. Okay. So the question we're trying to ask or answer, is what is the derivative of an exponential function, and how do we use shortcuts to get it? Okay. So goals for today, guys. We're looking at find the derivative of functions of the form a to the x. In this case, a is some number. Okay. And then the other part of this is find the derivative of functions of the form e to the x. Okay? Now guys, if you remember way back in chapter 1, you remember what that equaled? Way back in chapter 1, we talked about exponential and logarithmic functions.
Yeah, just be answer.
It'd just be an x, because a natural log function takes out your exponential base function, so this would just equal what? You might want to write that down. Recall this, okay? Recall that rule right there, okay? So what if I had this, guys? What if I had natural log of e to the 7? What would that equal? Just be 7. Okay, remember that. All right, my friends, here we go. Two vocab words, and the vocab words are really going to be the shortcuts to your new derivatives today. The first one says the derivative of any value a to the x. So when I write this right here, this is saying the derivative with respect to what variable here, kids? The derivative with respect to x of the function a to the x is equal to the natural log of a times what? A to the x. So suppose this. Suppose f of x was equal to, I don't know, how about, should we do that one that we had up there, 3 to the x, kids? Okay, its derivative then, my friends, would be simply this. Okay, it'd be the natural log of a. What are we considering to be the a value in this example?
3.
3. This would be the natural log of 3, that first part right here, times what?
Times x.
3 to the x. There it is. Okay? So the derivative of a to the x is the natural log of a times what, kids? A to the x. Now there's more to come with this here when we get more intricate with some of these and more detail to them. But for now, most of your exponents out here are just going to be a what? An x out there, okay? Next rule right here, derivative of e to the x. This is an interesting one. This one here says the derivative with respect to x of e of x is just what, kids? E of x. Ooh. The derivative of e of x is its self. Let's talk about why that's true, okay? If I gave you the function f of x is equal to, I don't know, e to the x like this. F prime of x then, according to that, is what? Okay, let me show you why. By rule right here, if you understand that e is some number, it's a natural number, about 2.718, right? Okay, here's how this would really work. If I follow the rule from up top of this right here, if our function was e to the x, f prime of x right here would really be the following. I could call it, and here's why this works out. I could call this the natural log of e times e to the x like this. But here's the deal. Based on that recall you had, this is really like e to what power right here, kids? Guys, we had that rule. If I have a natural log of e to the first, that's really what value? 1, isn't it? So that natural log of e out front really kind of just does what? Kind of goes away, doesn't it? This goes away. This is like 1 times e to the x. So that's why the derivative of e to the x is itself e to the x. Because the natural log of e is going to be what value here? Okay, 2 rules I want you to remember. What's the derivative of a to the x?
ln a times a to the x.
Natural log of a times a to the x. Understanding that a is some number, right? What's the derivative of e to the x?
Itself.
E to the x. Okay, here we go. Now, let's look at some of these here. Guys, don't get too scared about this. It says find the derivatives of the following functions. Okay, I don't like this square written here. Get rid of that for me. That's not there. This should just be 4 to the x, okay? All right. Let's do that first one right here. What would the derivative of this be in the middle?
Would be L, or natural log of 2.
Oh, I'm sorry, I'm on the second one here.
Oh.
I'm sorry, I'm kind of jumping out of order.
Okay. Well, would it just be natural log of 4 times 4 to the x?
Yep. That's pretty simple, isn't it? Okay, now the thing I don't want you to get worried about is sometimes we'll look at some things out here where I've got a multiple out front here. So we're multiplying by 2 in this next example. F prime of x, how many parts are there really to this derivative right here?
2.
Okay, we got to do the derivative of the first part here and then the derivative of the second part. So I'm curious to see what you do with this.
It would be the natural log of 2 times 2 to the x. Plus 2.
Plus 2. That's just 2 is just some kind of a constant multiple. So let me just back up here real quickly. If you think back to power rule, kids, let me put this up on the board. An example I used before was 8x to the 4th. You guys know the derivative of that would have been what?
32x to the 3rd.
32x to the 3rd, right? But I also said I could take the derivative of x to the 4th, which was what? 4x to the 3rd, and then times that by that constant out in front in the end to get an answer of 32x to the 3rd, right? Okay, so this is kind of the same thing. Isn't the exponential part happening right here, kids? So I can leave that constant of 2 out front that we're multiplying it and take the derivative of the exponential part, 3 to the x. So this would be 2 times, what's the derivative of 3 to the x?
The natural log of 3 times 3 to the x.
So this would be 2 natural log of 3 times 3 to the x. Okay, let me squeeze that answer in that box. There it is. Okay, do you understand the natural log of 2 times 2 to the x here for this first part right here, kids? Okay, do you understand why this 2 stayed out front here? That's this 2, and then times the derivative of 3 to the x would be that natural log of 3 times 3 to the x part. There's that derivative, okay? All right, let's see how good you guys are. Anybody want to take a shot at that last one? What if I told you that last one is very similar to this part right here?
Oh, so then it just be.
This is a tricky one. Isn't natural log of 4 some number? I just don't know what the number is. I could punch it in my calculator and get it, but isn't natural log of 4 some number?
Yeah.
Just like this 2 out front here and this highlighted part was some number out in front of the exponential part, right? So we're really differentiating what part, kids? So this constant of natural log of 4 is going to stay where? out front, right? This is gonna become, anybody wanna guess on this?
Natural log of 4 times natural log of 6 times 6 to the x.
Natural log of 4 times the natural log of 6. You got it. So when you see parts like this, they say, ooh, that's weird, the way they have it there. You gotta understand that the natural log of 4 is somewhat. Some number, or it's some constant, right? Just like this 2 out front here, the 3x was a constant, okay? This natural log of 4 is some constant. Yeah, you bet. You show of hands, are you on board right now? Okay, it'll get trickier, I guarantee you that, especially when we start, and notice, what have all of our exponents been for these, exponential functions? Just an x, right? Okay? There'll be times we start looking at it down the road where it's not just an x up here, and we'll apply new rules to that, okay? Alright, in your notes that go on forever, turn to just the second page we're on. Holy smokes, this is going to take forever to get through today. This is crazy. Who gives notes this long? Yeah. Okay. I'm not even going to talk about the first one. You go ahead and talk about the first derivative. Actually, I'm going to have you guys take about 3 minutes and 14 seconds. Why don't you guys try and do those 3 on your own right now? Talk with a neighbor when you're done, okay? I'm going to see what you come up with here. If you don't get it, don't worry. There's plenty of room. We'll get the right stuff up there. But take a couple minutes and do those. See what you've got. Check with someone around you, and then we'll come together as a group. Luke actually stabbed myself, Mike. You see that really good. First one should be pretty easy.
Yeah.
Anybody want to talk me through that first one there?
I got the natural log of 6 times 6x plus e to the x.
Did you say times 6x or 6 to the x?
6 to the x.
Okay. Plus what?
Plus e to the x.
Plus e to the x. How many would agree on that?
Yeah.
Okay, I like that. The derivative of 6 to the x, that's pretty straightforward. Natural log of 6 times 6 to the x. The derivative of e to the x, that's pretty straightforward, right? Okay. Yeah, let's see I want to see how you reacted to the second one. I tried to throw a curveball by you. I'm pretty sure you hit it out of the park, though. How about the derivative? Anybody want to guess the derivative of 7e to the x? It's still 7e to the x. It's like 7, that constant up front, times the derivative of e to the x. And the derivative of e to the x is just what that we learned today? 7e to the x. Be careful on this. Yeah, this is the power part right here. That's not exponential, is it? So this would be plus 2x, right? So here's the part on that right there. Am I gonna start mixing powers with exponentials? And the answer is obviously gonna be what?
Yes.
Yes, okay?
I don't think so.
All right, this next one, if anybody gets this next one right, I will be very impressed. Oh boy, anybody wanna take a guess at it? Anybody feel confident?
I will.
I'm listening.
Well, maybe not. The parentheses are throwing me off.
Okay, the natural log of 3 is a constant out in front, right?
Yeah, so the
So
natural
the
log.
function part's really x squared, isn't it?
Yeah, so it'd be 2x.
Okay, so I really pull that 2 where, kids?
Oh.
2 times that constant, couldn't I? So could I really call this 2 natural log of 3 times what, kids?
Times x.
X to the
It'd just be
first. Do you guys agree with that part there?
Yeah.
Okay, now again, natural log of 4 out in front of e to the x, isn't natural log of 4 some number?
Yeah.
Kind of like right here, it wasn't 7 some number out in front of e to the x? And what was the derivative of 7 e to the x? Well, it was itself, right? So what's the derivative of natural log of 4 e to the x?
Just be natural log of 4.
Natural log of 4 e to the x. Anybody have that? I'm curious.
Not even.
Okay. Give me a show of hands here. Do you understand why this is a power function? We gotta apply a power rule here. Power is a number, not a variable, so it's not exponential. This is gonna be a power function, so we pull that 2 out front. Natural log of 3 is some number. Like if this was 3x squared, you just said, oh, that's 6x, but this isn't a 3, it's natural log of 3, okay? Guys, those 3 examples right there should be a good start for you to do some things today on the assignment, but let me ask this question. How many are like, yeah, I'm comfortable with those 3 right now? Are we okay with that? Boys over here, good? Okay, what questions do we have so far, friends? Nada? I love this real life example. Here's the deal. It says an animal population is given by P of T equals an initial population of 300 times 1.044 to the T. Quick question, growth or decay? Why is it growth? Greater than 1. That part, that's the base. 1.044 is greater than 1. What's the percentage of growth? 4.4%. You guys are awesome. Where T is the number of years since the study of the population began. It says find what, kids? Okay, P prime of 5. Well, the first thing we need to know is P prime of T, don't we?
Yep.
All right, anybody want to help me with P prime of T? Okay, you got a constant 300 out in front of, this is like A to the T, isn't it, kids?
Yeah, so it'd be like 300 times the natural log.
So this will be 300, that constant out front, times, what's the derivative of the 1.044 to the T?
Natural log.
Natural log of, what value? Okay,
T.
times what?
T.
Almost.
Times 1.004 to the T.
Times 1.004. Oh, that should be 044, right?
Yeah.
I got a number wrong in there. Hang on.
Please, come on.
I know.
Silly guy. Hey, at least I tried. He's putting it. Yeah.
Okay, how's that look, kids, for derivative?
Looks good.
Okay, what do we ask to find in this case then?
P prime of 5.
So P prime of 5. So basically we have our derivative. Anywhere where there's a T, what value should I be plugging in?
5.
So this will become 300. Natural log. 0.044. Why do I want to put 2 zeros in there today, kids?
I don't know.
Times 1.044 to what power, kids?
5.
I don't know if anybody's crunching those numbers right now. If you are and get an answer, shout it out.
I don't know if this is right, but I got 16.02.
16.02, can I check and see? So what's the initial population here, kids? 300, so it's possible.
Oh, probably not.
I bet it is. 300 times the natural log of 1.044 times 1.044 to what power again? I got 16.02. Is that what you guys got?
Yeah, that's what I got.
Okay, so what this means, guys, is this. 5 years after the study, I'm just going to write down, can we just put 16 here? Is that okay?
Yeah.
Okay, I got 5 years after the study then. Let's say 5 years since the beginning of the study. That's what I should say because it's ongoing, right? It's the beginning. Of the.
Bless you.
Yeah, man. Five years since the beginning of the study, comma. Again, derivatives are always about a rate of.
Change.
Can I say the rate of change in population? Is 16, what would be the proper unit to throw on here?
Animals per year.
16 animals per year. So it's like in 5 years, it's like we were gaining animals at a rate of 16 per year, right? Very good. Guys, shortcuts and derivatives are kind of fun. How you feeling about your 2 new shortcuts today?
Yeah.
Feeling okay about that? Okay, let me get you an assignment here today. Probably throw the quick quiz at you tomorrow. Probably give you some time to work on these tomorrow with a little bit today too. But here it is. Let me write this down up on the board. It is page. Starts on page 201. Guys, I don't know about you. I feel like the first chapter took forever, and now chapter 2 and chapter 4 we're flying now.
I was really confident on it.
Everybody feeling the same way I am?
Well, okay, I got a 3.
Yeah.
I told you I wrote my book.
Person's putting grades in for next year already.
I want a triple, but she's making me take a double. Yeah. How did you get out? Reading after I was
Okay, my friends, right here, it's page 201. I'm asking you to do 21 through 21 odds. And then I'd like you to take a look at 31 through 35. And given that right there, I think we'll be pretty good. I can't wait for the next section. Product rule. Product rule is cool. Product and quotient rule. Okay, then the big one. We're going to talk about chain rule a little bit. And the chain rule is probably the most important thing in calc, if you ask me. Okay, I need to stop recording so I don't see anything wrong. So if you guys want to use the rest of this time either to finish up anything you have out right now or